Okay, in units 14 and 15, we're going to start to look at financial applications. So we will look at simple interest and compound interest in this unit. So when you borrow some money from the bank or any other lending company, you will always have to pay interest. So you're borrowing the money, they charge you interest, and then you have to pay that back. So there's a couple of different ways that we can calculate interest. Also keep in mind that you will earn interest if you put money in the bank. If you have a bank account or some sort of investment, the bank will pay you some interest on top of that. So the two different ways to calculate interest are simple interest and compound interest. So we're going to look at the two different types. Generally, we do not use simple interest. It's not commonly used, but we will look at how to calculate it. So, simple interest is interest earned only on the starting amount. Okay, so you only get interest on that initial amount, whereas compound interest is often referred to as interest on the interest because the interest is added on as we go. So the difference is, if we look at this table here, we are starting with $1,000 and we are getting 5% interest each year. So $1,000 times 5% as a decimal, 0.05, would be $50. So with simple interest, you're going to get $50 each year. Let's erase that. So every year you're getting $50. The interest is going to be $50. At the end of 1 year, you would have $1,050. The balance in the new year is $1,050, but you're still only getting $50. So now you're at $1,100. So your balance in the third year is $1,100. You're still only getting $50. So each year you're getting $50. And that is based on the original $1,000 that you deposited in this bank account. So if we look at the finite differences, we see that we're going up by $50 each time, which means that the first or finite difference is the same. So the finite difference is the first difference. So they are the same, which means we know that this from previous work is that will produce a straight line. It will produce a linear function because we're going up by the same amount every year. So I'm going to So let's just plot those points on this simple interest graph. So we started at 1,000. After 1 year, we were at 1,050. After 2 years, 1,100. After 3 years, 1,150, and so on. So that's going to produce a graph that is a straight line. With compound interest, we are starting the same amount, $1,000, at 5% per year. Sometimes you would see that referred to as per annum. So per annum means each year. So we're starting off with $1,000. The first year we're getting $50. We're at 1,050. So the starting balance on the second year is 1,050. This time you are getting interest on the new amount of 1,050. So now you're getting 5%. So this year we got 1,000 times 5%. The second year, we're getting 1,050 times 5%. So that value is $5,250. So you're making a little bit more money, and now you have $1,102.50. That's the starting balance for the third year, and you're getting 5% of that. So now you're getting $55.13. So the interest with compound interest is added on, and then the new interest is calculated from that new balance. So when we look at the first differences, let's erase this, it is not linear. If I subtract 1102 50 and subtract the 1,050, the difference is 5,250. And then this difference is 5513, and this difference is 5788. So you can see that it's not going to create a linear function. It's actually going to create an exponential function. So this one is linear because the first differences were the same. This one is exponential. So we start with 1,000. The first year we have 1,050. The next year is 1,102, so a little bit more. And then 1,157. So this one's going to curve up a little bit more. We'll just exaggerate it there, but it's going to be an exponential function. So the formula for simple interest is I. So if we just look at the interest separately, the interest portion is interest equals PRT. P is the principal, or starting amount. R is the interest rate, which is expressed as a decimal. And T is time is year, in years. So this is the interest portion. You'll notice that the final amount is the starting amount, and then you add the interest on. So if you want the final amount, you have to add the original amount on. So, for example, if Janine borrowed $500 for 2 years and was charged 8% simple interest, how much did she owe at the end of the 2 years? So the starting amount was $500. The interest rate was 8%. We want to write that as a decimal. Remember, when you want to change 8% to a decimal, you divide by 100. And then time in years was 2 years. So if I want to know the amount at the end, I'm going to do the starting amount and then add the interest. So the starting amount she borrowed was $500, and then the interest was $500. Let's just put these in individual brackets. Times 8% for 2 years. So the interest portion is $80. So at the end of the 2 years, she would owe $580. That includes the $500 that she borrowed, and then the $80 is the interest that was charged. Okay. Julian borrowed $8,000 for 20 weeks and was charged 5.25% simple interest. How much did he have to pay back at the end of 20 weeks? So the principal is the $8,000 that he borrowed. The rate is 5.25%. So if I divide that by 100, I get 0.0525. And then time has to be in years. It's given in weeks. I know that there are 52 weeks in a year. So we have to divide by 52 to determine time in years. So I'm just going to leave it as 20 over 52 because it does give me a decimal. I would be more accurate if I left it as a fraction. So the amount is going to be the principal, 8,000, and then the interest will be the principal times the interest rate times time in years, which is 20 over 52. So I'm going to multiply 8,000 times decimal 0.0525 times 20 and then divide by 52 because 52 is on the bottom. And I want to round to dollars and cents because we're dealing with money. So $161.54. So final amount is $8,161.54. So that's how much you have to pay back at the end of 20 weeks. Okay, and then in this example, Mirza borrowed $1,200, so that's my principal, for 3 months and charged an interest rate of 2.75%. So again, we have to divide that by 100. So decimal 0.275. Time, this time is given in months, so we have to change it to years. There are 12 months in a year. So if I divide 3 by 12, we get a, I'm going to change that to a decimal because it is an exact decimal. It's not a repeating, so we can use 0.25. So how much would he have to pay back at the end? He would have to pay back the $1,200 he borrowed, plus the interest. So let's calculate the interest to add on to the 1,200. And that is $8.25. So he would owe $1,208.25. So that is simple interest. In the next lesson, we will look at compound interest.